All right. Good evening again, Jason, Jerson, Leilani, Aline, Merwin, Ian, Mary, and Becky. So, how are you guys? Kumusta? Uh,
Okay
can
naman
you
po,
hear?
sir.
All right. Thank you,
Okay naman
Jerson.
po, sir.
Okay. Kahit na pinagdaanan nyo na yung modules in the last couple of days, hopefully. So, let's see. Yeah. First, I would like to apologize for the abrupt cancellation of yesterday's tutorial. Something came up, and I had a boo boo. I forgot that Moodle has a 13-minute delay before announcements are posted right away via email. So kanina ko lang naalala. So by default, so ganun yung ginagawa ni Moodle. So I have to turn the 30-minute delay off. So kaya kanina siguro mas mabilis niyo nakuha yung messages, but I do apologize for again missing the or canceling the tutorials, and for probably for some of you who waited 30 minutes or more in the meeting room yesterday. But here we are on a Saturday night. I don't know, because of your love for math or for sheer sheer necessity. So that's why you're here and joining me this fine Saturday evening. But the idea is for us to I don't know, based on how you feel. So I would really love to hear from you. What do you want what you want to do today? So I can either just answer your questions, especially questions about the homework, or questions about the text, the modules that you were reading, or I can go through the module one time, or not one time, but I can discuss the salient points of the module, so that you'll be guided, especially for those who are first seeing this. I don't know. Ilan ba sa inyo first time nakita yung mga topics na nandun sa module? Specifically the concept of fields and the properties of a field. Sino yung first time? Can I see a show of hands? All right, so I think a lot of you are seeing, yeah, 3 of you are seeing it for the first time. How about the others? So what do you think should we do? Antayin ko lang ba yung mga tanong nyo, or probably I'll go through the module topic by topic and explain some salient points on there. What do you think should we do? Any suggestions? Ayaw nyo pa rin magsalita.
If possible, sir, yung ano po, go through the module.
Okay, sure, yeah. Let's do that. Hold on. Yes, Aline, you want to say something? Or hindi lang nababa yung button? May delay yata yung share screen ko, so let's hope this will be better as we go along. Okay, so let's go through the module topic by topic, so that you'll be guided, especially ganito nyo, para makita nyo kung paano babasahin yung module, because this is probably new to some of you. This could be too technical for some of you, and then siguro I know some of you have done proving years or decades ago, or who haven't done it at all. So siguro magbibigay rin ako ng example ng proofs as we go along. We'll write it together if they are not in the modules yet. So ganun na lang, so mini discussion yung gawin natin. So the target is hopefully we'll be able to look at the parts of the modules pertaining to the first homework. So you'll be guided, because I guess the tentative deadline for the homework is fast approaching. Parang after the holiday, deadline na ng homework number 1, but we can easily move it if you need more time. So let's see. So this is linear algebra. We're going through chapter 1. This is very different from the linear algebra that you probably took during your undergraduate years, unless you are a math major. So this is more of an abstract or a theoretical approach to linear algebra, We will not be starting it as the study of matrices that are used in solving linear systems of linear equations. Kung natatandaan nyo noon, parang ang simula ng linear algebra, meron kang system of linear equations, gusto mo silang isolve using different techniques. Hindi pa nag-start sa matrix inverse, nag-start pa tayo sa Gaussian elimination. You form the matrix, you perform elementary row operations, and then you get the solution to a system. And then from there, you will discuss the concept of an adjoint. You'll discuss the concept of the inverse of a matrix. You'll go through eigenvalues, eigenvectors, singular values, singular vectors, and so on. So that is the more computational treatment of linear algebra, and that's a treatment which views linear algebra as a tool to answer mathematical problems. But in this particular course, we're looking at linear algebra as its own theory. All right? So kaya titingnan natin ano yung mga components, so ano yung mga properties, ano yung mga magagandang laman ng linear algebra that allows us to do those things that we were doing in high school or in college. So really, it's justifying everything. What is the foundation behind linear algebra? Oh, by the way, is there anyone who can't understand Filipino or Tagalog? So pwede naman yata akong mag-Tagalog every now and then, no? So any foreigner in the class or anyone? Okay, so I guess I'll take that as a go signal to trans language to switch between English and Tagalog. All right, so I hope that's fine. So yeah, the foundation of linear algebra is really on the structure, how we work on this structure. And this will not begin with matrices as you have done before, because essentially yung linear algebra, I study of linear transformations or functions that has this linear property. We'll talk about them later. And then you might be thinking, sir, saan papasok yung mga matrices? Matrices are just a computational manifestation, a computational representation of these linear transformations. So really, it is a study of nice functions from vector spaces to another vector space. So really, ganon yung tunay na linear algebra. Study ng mga functions between vector spaces. And matrices only come as a representation of these nice linear transformations. So, kaya kailangan nating munang tingnan ano yung mga itsura ng mga functions between vector spaces. And that requires us to talk about vector spaces. Tapos bago ka pa makapag-usap about vector spaces, kailangan muna natin yung konsepto ng tinatawag natin na mga abstract fields. All right? So essentially, the first part of module number 1 talks about fields. Ano ang isang field? Ano ang mga properties na meron sa isang field? Ano yung mga components ng isang field? And that's what we want to do in this module. So essentially, the module combines the study of fields and vector spaces. So here are the module objectives that you should be able to do. So verify that a given set together with a binary operation is a field. Check whether a set together with two operations is a vector space over a given field. And then, of course, you need to prove some statements about fields and vector spaces, right? So let's move on and take a look at ano nga ba yung tinatawag natin ng mga fields at mga vector spaces. But of course, let's have our notation straight first. Ano? So here are the number sets that we will be working with. Ito yung mga notations na gagamitin ko all throughout the module. So first, double struct n. So para lang siyang letter n, tapos nilagyan mo ng guhit dun sa gitna. So the double struct letter n is the set of natural numbers. So that's 1, 2, 3, and so on. So ang convention natin, I'll start the set of natural numbers at 1. Yung iba nag-start sa 0, pero simulan natin sa 1 yung natural numbers. And then double struct z, or simply z, is the set of integers. So the negative of the natural numbers, 0, and then the natural numbers. And then the set of rational numbers, q. This is the set of all possible ratios of integers. And then probably we'll use QC for the set of irrational numbers. Ito naman yung mga hindi kayang i-express as a fraction. So then I'll use the upper script C or superscript C para i-denote yung complement ng isang set. All right? And then R is the set of all real numbers. C is the set of all complex numbers. So these are the numbers of the form A plus B times the imaginary unit. I is the number such that I squared is equal to -1. And then if I'm talking about just specific subsets of the sets above, pag nilagyan ko ng plus yung isang set na na-define natin kanina, yun yung set ng mga positive members of those set. So if I write R plus, this is the set of all positive real numbers. If I write Q plus, set of all positive real numbers. Okay? But if I put a circle inside a plus, say I write this would be the set of all non-negative rational numbers. So this would be all the positive real numbers plus 0. Okay? So okay tayo sa mga notations. So if you are not familiar with them, you'll be forced to be familiar with them because we'll be using them over and over again. Okay? Now we'll start defining what fields are. Fields are essentially algebraic structures that possess several properties. What are these nice properties? These are the properties that makes them well-behaved because ito yung mga properties na nag-a-allow sa atin na gawin yung mga bagay na itinuro sa atin since elementary. In particular, this allows us to solve for linear equations. All right. So ito lang yung mga properties na kailangan ko sa isang set of objects together with two operations that will allow me to do or to solve equations, which is something that we have done before. All right. So talagang pag nag-aaral kayo ng abstract math, lagi lang nating gina-justify ano yung mga bagay na ginagawa na natin, ano yung mga properties ng real numbers that allowed us to do those things, and then we try to extend them into abstract objects. Kasi alam natin mag-solve ng equations over integers or over natural numbers, over real numbers. Pero ang matututunan natin sa abstract algebra ay pag pala yung properties na yon na meron yung real numbers, rational numbers, etc. ay binigay mo sa isang set ng kahit anong objects. Pwede pa rin pala tayo mag-solve ng equations gamit yung mga objects na yon. So hindi lang pala mga numbers ang pwede nating paglaruan via equations. So ito yung mga properties na ibibigay ko sa inyo ng isang field. Because again, these are the properties that allowed us to solve for solutions of equations or at least linear equations before, right? So medyo mahaba yan. And I don't know, for the non-math majors, I am very fond of notations. So I'll throw again a bunch of notations for you guys. If I write an upside down letter A, we read this as for all or for every. We call it a universal quantifier. All right. So ibig sabihin lang to, for all, whatever will follow. So if I write this and that means for all x. If I want to say, or if I want to write the for all real numbers, what I'll write instead is for all x in R. Right? Medyo mahaba kasi pag sinulat ko yung for all real numbers. But if I write for all x in the set of real numbers, I'll write it symbolically using this bunch of characters. Okay? And then the mirrored E naman, ito yung tinatawag natin na existential quantifier. We read this as there exists or there exists. So depende dun kung ilan yung sinasabi mo na nag-exist na member. All right? And then I use ST for such that. Other notation for such that ay ganito. Pero I'll stick to ST para hindi siya magmukhang alien looking. What else? I use IFF for if and only if. So, and then other notations that I'll use, introduce ko na lang later. If there's a weird symbol that I haven't defined, but I use it somewhere, please tell me, call my attention so that I can define them properly. Okay? Readiness, so definition number one. I think we're ready to look at what comprise a field or what are the properties, the nice properties I was alluding earlier that is required for being a field. But hold on, guys. Give me 30 seconds. Sorry. Maghapon ako nag-hibernate. Tapos, kung kailan ako magkaklase, saka lumalabas yung allergic rhinitis. So I'll need to mute myself from time to time just to free my nose of this stuff. Ano? So sorry about that. Okay, so let's go. Let's define what the field is, right? So para magkaroon ka ng isang field, kailangan nating tingnan or i-verify na nasa-satisfy nung structure na yon itong definition number 1. So what are the requirements in definition number 1? We need a non-empty set F. So we start with a non-empty set F together with two binary operations on that set. Well, anong ibig sabihin natin with binary? Ibig sabihin lang ng binary, you take two members of F. All right? And that's fine because F has some elements. Si F ay may laman, non-empty set siya. So para magkaroon ka ng binary operation, kailangan pag kumuha ka ng dalawang members ni F at pinag-operate mo sila, dapat ang sagot ay na kay F pa rin. Right? So that's what we call the closure property. So what to be a binary operation, I should take two elements of the set F, I operate on them, and if the answer is still in capital F, then we say that the operation is closed or the set is closed under the operation. And that operation is a binary operation kasi two at a time yung pinag-ooperate yan na members ng set F. For a field, kailangan natin ng dalawang binary operation. Usually, ang tawag natin sa mga binary operations na yun ay addition and multiplication. Not necessarily the usual addition and multiplication that we know. Because remember, I am not saying that F is a number set. Si set F ay kahit anong set na merong laman. All right? So it doesn't necessarily be a set of numbers. So yung addition at multiplication na binabanggit to be binary operations, they are not necessarily the usual addition and multiplication that we know. These are just the names we are giving to the two binary operations that comes with the set F, right? And then we are adopting the name, so why not adopt the symbol? So i-denote natin by plus yung addition, tapos dot or concatenation yung multiplication. So really, what will happen is that if A and B are members of your capital F, gusto ko yung A plus B ay na kay capital F pa rin. Kasi I want addition, denoted by plus, to be a binary operation. I took two members of the set, si A at saka si B, galing sila kay set F, so dalawa, kaya binary, pinag-operate ko sila under addition, yung sagot nagbilong pa rin kay F. And if this is true for all A and B in F, then I can say that the set F is closed under addition. Okay? Is that clear? Medyo technical na yung mga sinasabi ko, so let me know if things are not making sense. At huwag mahiya, if it's not really making sense, tell me, all right? Kasi kailangan nating maintindihan to before we move on because math is a sequential topic. You build a new topic from the previous one. So if the foundations are shaky, then mahirapan tayo pag nagpunta na tayo dun sa mga mas mahirap or mas advanced topics. Okay? That good so far? All right? Okay. So, meron ka ng set F, meron ka ng addition, meron ka ng multiplication, kailangan nating sabihin ano yung mga properties ng tatlong objects na to para itong structure consisting of these three guys will comprise a field. All right? Medyo marami kayong dapat i-check. Una, dapat associative yung dalawang binary operations. This is the usual associativity that you might have been teaching sa inyong mga elementary or high school students. Associativity, ibig sabihin lang the ordering, or sorry, the grouping doesn't matter. All right? So symbolically, this is how it is laid down. So pag si A, B, C ay mga members ng non-empty set F, well, if you have A plus the quantity B plus C, so tingnan natin ano pang ibig sabihin nito and how is it different from the right-hand side, because it might be very obvious for us since we are living in the real number system with the usual addition and usual multiplication. You might be thinking, why are we still writing this down? Isn't this automatic? Again, this is important because the set F we are using in this definition is not necessarily the set of real numbers. It might not be numbers at all. So pwedeng ang laman niya ay mga apples, mga bananas. So that and then out of the blue we define addition and multiplication on them. So it's really important that we laid out all these properties. Pero what's the difference between the two sides of equation 1? Anyone would like to tell me ano yung pinagkaiba nito at saka nito? Or tries? Better if you can unmute yourself, or if not, type in on the chat. Pero mas maganda yung ano na lang, verbal na lang. Nakita ko si Aline. Alright, thank you.
Po ng mga variables.
Okay, thank you, Aline. That's perfect. Magkaiba yung grouping ng variables, and the grouping are very important because, as Aline said, in the left side, you have B and C grouped together in an addition, and on the right-hand side, A plus B is grouped under the addition. So, ibig sabihin dito, kasi di ba binary operation, dalawa lang at a time. Hindi pwedeng tatlo sabay-sabay mong ina-add. Although theoretically, practically, nagagawa natin yon, pero associativity allows us to do that, or together with commutativity and probably some other properties. But essentially, kailangan 2 at a time lang yung pinag-a-add natin. Binary operation siya. So dito, sa left-hand side ng equation 1, kailangan ko munang i-add yung B at saka C together and get another member of F before adding the result to A. So B plus C is a different symbol, or this is a different value. So I need to find out first what's the result when I add B and C together before adding it to A. Kasi nga, dalawahan lang lagi ang addition. Meanwhile, on the right-hand side, we have A and B grouped together, so we really need to answer A plus B first before adding the result to C. But if addition is associative, then these two guys will be equal to each other. All right? The same thing happens for the multiplication. So para magkaroon ka ng field, dapat associative muna yung dalawang operation, yung addition saka yung multiplication. Right? So, and that should be true for all A, B, and C in capital F. Lahat dapat ng A, B, at saka C doon sa set F nakakasatisfy netong properties na to. All right? So that's the first thing you check, associativity. Pag hindi associative yung addition and multiplication in your set, then automatically hindi na siya field. You don't need to proceed to check the other properties. That will be waste of time. Kasi nga pag may isa siyang hindi na satisfy, hindi na siya field. Okay? All right, next property is commutativity. Commutative dapat yung addition at saka multiplication, meaning the order of performing the binary operation is not important, because whichever you put first will give you the same answer as putting the other one first instead, right? So that means A plus B should be equal to B plus A, and A times B must be equal to B times A for all A and B in the set. Okay? Ordering is not important. Okay. Sorry pala, medyo nagiging college teacher ako. So am I treating the discussion too elementary for you, or okay lang? I don't know. Baka nababagalan kayo, or
Okay na okay, sir.
okay, mas gusto niyo ba
Okay
ng
po,
ganito?
sir.
Baka magalit
Yes
kasi kayo sa akin kasi parang baka isipin niyo tinitreat ko kayo as undergrads, ano? So, pag medyo mabagal, sabihan niyo ako, alright? Okay, third property. The third property is probably the first and probably the only property that intertwines addition and multiplication, because you see property 1 and 2, associativity and commutativity, pwede nyo magkahiwalay i-check yung addition at multiplication. Associative ba yung addition? Associative ba yung multiplication? Commutative ba si addition? Commutative ba si multiplication? You can do them independent of each other. So hindi magkahiwalay yung pag-check ng addition and multiplication. In property 3, dito na nagmamatter yung kung sino yung addition at kung sino yung multiplication. Kasi property number 3 requires the distributivity of multiplication over addition. Word of caution, magkaiba yung distributivity of addition over multiplication. Para sa isang field, yung pangalawang operation, yung multiplication, dapat ang pwedeng i-distribute over the first operation. Alright? So, siguro hindi siya ganun ka-importante for you now, pero importante siya. So, dapat yung multiplication ang nadidistribute sa ibabaw ng addition. So that means you need to multiply an element of f over a sum, right? So it would be 8 times the answer to b plus c. So to check distributivity, you need to know whether this is equal to a being distributed inside the parentheses governed by the addition. So dapat yung a times b plus ay equal, yung a times b plus c ay dapat equal sa a times b plus, i-distribute ko si a dun sa pangalawang addend, so that will be ac, right? So this is distributivity. Distributive dapat yung multiplication doon sa addition. All right? And this is the usual thing that we know from elementary, right? Pero ngayon nga, yung A, B, at saka C, hindi na sila necessarily mga numbers ngayon. Okay? And then pang-apat ay existence ng identities para sa addition at multiplication. Identities are members of the set F. Sila yung mga members ng set F na parang walang effect pag ginamit ko sa addition at saka sa multiplication. Right? So meaning this elements preserves the identity of whatever is added or multiplied to them. Okay? So halimbawa sa usual addition of real numbers, sino yung yung quote unquote walang ginagawa with respect to addition? Na pag inad ko siya sa isang number, walang effect. Na-preserve niya yung identity nung sinong pinag-addan ko.
Zero. Zero, sir.
Yeah, thank you, Jerson. Yeah, si zero, right? So si zero, siya yung additive identity sa usual addition of real numbers. And in multiplication, 1 serves as the identity in usual multiplication, right? Because if you multiply a number to 1, the answer is the number itself. And this is true for any number in the set of real numbers. So sila yung nagpe-preserve ng identity nung mga elements ng set, right? So, and since we already know 0 and 1 to be the usual additive and multiplicative identities, usually sila na rin yung ginagamit na members, ginagamit na symbols para kay F, all right? So just put at the back of your minds that the 0 and 1 here are not necessarily the numbers 0 and 1. Sila lang yung symbols na gagamitin natin para i-denote kung sino yung additive identity, that is the 0, and the multiplicative identity, siya si 1. Right? So usually ang tawag natin dito ay 0, ang tawag natin dito ay unity. So yung 0 nung set, ito yung unity nung set. Right? The 0 of the set is the additive identity, while the unity of the set is the multiplicative identity. The 0 element is the number that you add to any member of the set, you get the number back, and the unity is the number which you multiply to any member of the set will give you the same number back, right? And this should be true para sa lahat ng A at saka A dun sa set F. Okay, good? Sige, mamaya mag-consider tayo ng ibang mga set at ibang mga operations. Maghanap tayo ng additive at saka multiplicative identities. Okay. Now, after you have established the existence of identities, dapat magkaroon naman ng inverses under addition lahat ng members ni F. So for all, you look at the symbol, for all A in F, sa lahat ng members ni A, lahat ng members ni F, Pangalanan natin silang A. Sa lahat ng A na nakay F, may nag-exist dapat na member. Ang notation dun sa member na yun ay negative A. Such that pag inad ko si negative A kay A, ang sagot ay 0, which is the additive identity. We call negative A the additive inverse. Because and what the additive inverse does is it brings back the number to the 0 or to the additive identity, right? So yung additive inverse, siya yung kailangan mong i-add doon sa element ng set para makuha yung additive identity. Remember, pinangalanan na natin o symbolize natin yung additive identity to be the 0. So the question is, if I give you a number and I ask you to get its additive inverse, you need to look for what is the number that should be added to A to get 0 back, right? So yun yung pagkakaroon ng additive inverse. At ang requirement dito, lahat dapat ng elements ni F may additive inverse. Okay? And then a little different, last property, dapat mag-exist ang multiplicative inverse para sa lahat ng non-zero elements ni F, right? So, katulad pa rin nung additive inverse, yung multiplicative inverse, siya yung number na kailangan mong i-multiply doon sa member ng set para mapabalik yung multiplicative identity. Sino ang multiplicative identity natin? Siya si unity. So if I give you a number A or an element A, you need to look for the number A inverse or the element A inverse such that pag pinag-multiply ko si A at saka si A inverse, ang sagot ay unity or the multiplicative inverse. The only difference or between property 5 and 6, aside from the addition and multiplication aspects, ay ang multiplicative inverse dapat mag-exist lamang sa mga non-zero elements. Si 0, wala siya talagang multiplicative inverse. Pero sa additive inverse, dapat lahat, including 0, should have an additive inverse. Okay? So yon yung 6 na mga bagay na kailangan yung i-check para ma-prove ng isang set ay isang field. Okay? Medyo mahirap yan, lalo na yung associativity. Medyo mahaba yung proof ng associativity. But I hope these 6 properties are clear. Any questions? Ginagawa niyo na ba ito sa abstract algebra?
Di pa po kami nagsa-start, sir, sa abstract.
Hindi pa kayo nag-start sa abstract. Okay, good. Sa abstract kasi magsisimula pa kayo sa groups. So mag-start kayo sa isang operation, dapat associative yung operation na yon, may additive inverse at saka may additive identity at may additive inverse. Kaya ka magkakaroon ng group. Pag commutative yung operation sa group, isa siyang abelian group. Alright. So parang ganito rin yung sa field. Connection nyo doon. Ang isang field ay may dalawang operations of course, but the first operation together with the set constitutes an abelian group. Then the set minus 0 together with the second operation constitutes an abelian group. And if the multiplication is distributive over addition, meron kang field. So kaya ko sanang isulat itong 6 na properties na to down to 3 kung nakapag-abstract algebra na kayo. Kaya lang, di pa kayo nakapag-abstract algebra, so kailangan ko siyang isulat in expanded form na 6 na properties. So actually, yung iba nga 12 properties or 11 properties yung sinusulat para sa field. But pinagsama-sama ko yung iba rito, so we need to check 6 things. All right? Okay. And then I have some remarks here. You can read them on your free time, right? Yung mga importante naman sasabihin ko, pero siguro mga kwento ko yon or mga insights before. But usually I write modules as if I'm talking to the student. So ito rin usually yung script ko. So I might be able to mention the things that I'll be skipping all throughout the discussions. So kaya I will not go through all of those remarks. So you just read them or highlight them when you're reading it on your own. Okay. So to take advantage of the usual notations that we know or that we are using, so introduce pa tayong ibang mga notations. Dalawa lang yung operations dito, di ba? So kung nasa field ka, addition at multiplication lang yung properties. Now, to take advantage ng mga notations na meron na tayo, so yung A plus the additive inverse of B, pwede nating isulat as A minus B. Because you might be thinking, sir, bakit tayo may A minus B? Dalawa lang yung dalawa lang yung operations natin. Addition and multiplication lamang. Well, A minus B is just our shortcut for writing A plus the additive inverse of B. All right? So yun yung nangyayari sa A minus B. And then if we have A times B to the negative 1, all right? This is A multiplied by the multiplicative inverse of B, we can write it as A over B, right? So itong division na to ay hindi talaga siya nag-exist as a division because division is not an operation we know in our universe. Kasi ang universe lang natin ay si set F na may addition at multiplication. If you see a division problem, that means we are multiplying A by the multiplicative inverse of B. Just to use or to take advantage of the usual notations we grew up with. Okay? And then kapag ka nag-a-add tayo ng n ng mga same elements, pwede natin siyang isulat na n times A. Right? Kasi there would be some times that we'll be working with non-numbers. Halimbawa, I'm working with the field consisting of fruits. Tapos meron ako mga crazy operations na dinefine doon. So pag nagkaroon ako ng 3 times banana, kunwari, ito ay equal lang sa banana plus banana plus banana. Right? So kaya pwede ako mag-multiply ng natural number sa kahit na ano pang object, all right? Because in a sense, that just means I am adding that element of the set to itself n times. Okay? Kaya kahit hindi integer, kahit wala yung mga natural numbers dun sa ating set F, okay lang na makakita tayo ng notations na natural number times a member of our set. Because at the back of our minds, that's just a shortcut in writing this long summation. Then ganun din sa exponentiation. Pag nakakita kayo ng banana cubed, this is just banana times banana times banana. Right? Para lang mas maiksi silang isulat. And then, usual sigma notation for addition. So you are just adding a bunch of a sub k's, k going from 1 to n. And here we're just multiplying a sub 1 until a sub n. But again, the addition and multiplication in equations 14 and 15 are as defined kasama nung field, not necessarily the usual addition and multiplication that we know, right? All good? Puro notations pa lang, no? Isa pa lang yung definition natin na pinag-workan. And this is usually how mathematical discourses are being done. Meron tayong tinatawag kasi na axiom of ignorance. Ang alam nyo lamang ay kung ano yung na-define at kung ano yung na-prove, nothing outside of that of those things. So that's why we usually lay down everything at the start of the discussion. Okay? All right, so before we go to example, I decided why not introduce the concept of a subfield. Para as we go through the examples, alam na natin ano yung ibig sabihin ng isang field, ng isang subfield. So, to get a subfield, kailangan mo na meron kang field, right? So kung meron kang field, say F, addition, and multiplication, tapos kukuha ko ng subset ni F. Tawagin natin G, yung subset ni F. Are you guys familiar with subsets? Do you remember kailan si G ay subset ni F?
If all the elements in G ay makikita sa elements ng F. Jose.
All right, thank you, Ian. That's correct. So si G ay nagiging subset ni F kapag ka lahat ng laman ni G ay na kay F din. So if you'll draw a Venn diagram for this, kung ito si kung ito si F, dapat si G ay properly contained kay F. Lahat dapat ng laman ni G ay na kay F pa rin. So, a subset is actually somewhat smaller than the set F itself. It could be the entire set F because the set F is a subset of itself, but generally, parang mas maliit lagi si G kesa kay F. Unless si G ay equal kay F, pero subset pa rin sila ng isa't isa. So, you take almost a smaller set, G, that is a subset of F, then si G ay magiging subfield ni F if and only if si G together with the restrictions of addition and multiplication in F to G is a field. So, ibig sabihin, parehas yung addition at multiplication na ginagamit natin kay G. Kasi lahat ng members ni G ay na kay F din. So, yung addition kay F at saka multiplication kay F ay pwede mo ring i-apply dun sa mga members ni G. Tapos, lahat ng pag nag-add ka ng members ni G at nag-multiply ka ng members ni G, nandun pa rin siya kay set G. So, closed si G under both addition and multiplication. Tapos, nasa-satisfy niya lahat ng properties ng isang field. So, si G ay isang field. Alright? Si G ay isang field together with the same addition and multiplication as in F. Then we say si G ay subfield ni F. Parang anak na field siya ni F. But the crucial things are, si G dapat subset ni F, tapos yung addition at multiplication ni F at saka ni G dapat ay parehas na parehas. Kung si G ay field pa rin, then it is a subfield of F. Okay? So let's look at some quick examples. The set of rational numbers and rational numbers together with usual addition and multiplication are fields. Kasi alam na natin from elementary, ang addition at multiplication ay parehas associative. Kaya pwede tayong pumunta ng, mamaya pa pala sa commutativity. So, but yeah, they are associative. We all know that. Dahil associative ang addition at multiplication sa R, associative din sila kay Q, right? Kasi si Q ay subset ni R. Lahat ng properties ng addition at multiplication kay R ay nai-inherit ni Q, right? So that should be fine. Commutative ang addition at multiplication ng real numbers. So by inheritance, commutative din ang addition at multiplication kay Q. Yan yung dahilan kung bakit pag pumunta tayo ng supermarket, pwede lang kumuha yung cashier ng kahit anong object from our baskets at i-punch without regard to order kasi parehas lang naman yung sum ng presyo na babayaran natin kung nauna man yung petchay kaysa dun sa binili mong bigas or something like that, all right? So, ganon, commutative siya. Ano ang then we know that usual multiplication is distributive over usual addition. So that's property number 3 sa check. Ano ang additive inverse natin? 0. Kasi pag in-add natin si 0 ay wala siyang effect dun sa identity ng sagot. Alright? So that's fine. Multiplicative identity natin ay 1. Tapos, ano ang additive identity ng isang real number? Additive inverse. So, nasa property, property 5. Dapat lahat ay may additive inverse. Pag binigyan ko kayo ng number, halimbawa 5, anong additive inverse ni 5?
Negative 5, sir.
Yan, negative 5. Pag binigyan ko kayo ng negative 3, ang additive inverse niya ay
3.
3. Right. Thank you, Jerson. So, yeah. And you can do that for any real number, right? So, ang additive inverse lang ng isang real number ay yung negative niya, right? So, if you have a real number A, ang kanyang additive inverse ay multiplyan mo lang ng negative 1, right? We can do this for any real number. So, lahat may additive inverse. So, how about multiplicative inverse? How do we get the multiplicative inverse of a real number? Ano yung minumultiply natin sa isang real number to get 1? the multiplicative identity?
The reciprocal, sir.
Great, thank you, Ian. Yeah, the reciprocal. Siya lagi yung multiplicative inverse. Kaya lang, hindi lahat ng numbers may reciprocal. Sino yung number na walang reciprocal?
Zero.
Zero, sir.
Yeah,
Zero.
great. Thank you, Richard, Jerson, and Ian. Yes, zero. Wala siyang reciprocal. So bakit naging field pa rin si R? Eh, walang multiplicative inverse si zero.
Not counted po yung zeros.
Okay, great catch, Ralph. Yeah, thank you, Ralph. Kasi naman, hindi required na magkaroon ng multiplicative inverse si zero, right? Remember property number 6, all non-zero elements should have a multiplicative inverse. So exempted si zero mula sa pagkakaroon ng multiplicative inverse. Alright? So dahil na-satisfy ni R, addition at multiplication, lahat ng 6 na properties na nakalista sa definition 1, it is a field. Alright? Tapos, dahil si Q ay subset ni R, at si Q ay isang field din, together with addition and the usual multiplication of real numbers, then we can say that Q is a subfield of R. Okay? So, yun lang yung kailangan para magkaroon ka ng subfield. Medyo mahirap mag-prove ng pagiging field, ano? Kasi marami kang properties. And I guess for those who tried some of the problems in the homework, medyo mahaba yon. So try to do that. I guess I have some examples here pa to show that. Yes, Sol?
Sir, dito sa item number 5, condition number 5, yung 0 po dito ay yung real number lang na 0 or yung additive ay yung 0 in general po talaga. Ibig sabihin, ine-exempt natin lahat ng additive identities from having a multiplicative inverse.
Great question, Sol. So sa definition 1, lahat ng 1 at saka 0 na nakikita nyo, sila yung multiplicative at saka additive inverse respectively. Additive identity respectively. So itong 0 na to na exempted sa pagkakaroon ng multiplicative inverse ay yung additive identity. Right? Not necessarily the number 0. Kasi merong mga operations na ang additive inverse ay hindi yung 0 number. It could be another number. All right? So kapag ka hindi 0 yung additive identity ang exempted sa pagkakaroon ng multiplicative inverse. Dito na mag-start magulo yung mga buhay natin, ano, when talking about these things. Yeah.
Thank you, sir.
Pero yeah, good point, Sol. Yung additive identity ang hindi kailangang magkaroon ng multiplicative inverse. Right? Okay, meron pang isang example. Halimbawa si Z2 which is the set containing the symbol 0 and 1 together with addition and multiplication defined this way, right? So ito yung isa sa mga examples ng hindi usual yung addition at multiplication. So this is what we call, or these are what we call Cayley tables or operation tables. Para siyang yung version ng multiplication table na meron tayo pero arbitrary yung operation. So halimbawa rito, ito yung addition table ng Z2 ng 0, 1. So 0 plus 0 is 0. If you want to add 0 plus 1, ang sagot ay si 1. Right? That's how you read the addition table. So 1 plus 0 is equal to 1 and 1 plus 1 is equal to 0. Okay? So ganyan yung addition sa Z2. Yung multiplication naman, 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 1 ay 1. So ganito yung operation sa Z2. Now, you can check that Z2 together with this addition and this multiplication is a field. All right? So yung associativity, yung commutativity ay pwedeng i-check exhaustively, all right? But I'll tell you later how it is checked when we go to the modulo example. Pero yes, you can believe me for now that they are associative and associative and commutative. Ano yung additive identity? So punta kayo sa operation table kay plus. Ano yung additive identity na pag in-add ko doon sa elements ni Z2, walang epekto? In short, what is the zero of Z2?
It's 0.
Yes,
sir.
Richard?
0.
Yeah, it's 0. How did you find 0?
Yeah, from the table. That if we add
Mhm.
if we add, for example, any element in Z2 plus 0 gives you the same. Gives you the
Great.
same. Yeah.
Yeah. So para bang naulit lang yung header, Kasi pag nag-add ako ng 0, naulit lang, walang effect yung addition by 0 kasi na-preserve niya yung nasa taas. Ganun din yung column header. Tingnan niyo tong 0, 1. Pag nag-add ako ng 0 sa dalawa na to, nag-add ako ng 0, walang nabago. So naulit lang yung column header. So 0 indeed is the 0 of Z2. How about the unity? Ano ang unity ng Z2? What's the multiplicative identity of Z2? So ganun pa rin. Hanapin. Yeah, thank you, Sol. So probably what Sol did is to look at when is the column header and the row header were repeated. So you look at 0, 1, check mo, si 0 kaya yung unity? Kaya lang, pagka nag-perform ako ng multiplication by 0, ang sagot ay 0, 0, hindi siya katulad nung nasa column headers, so hindi siya multiplicative identity kasi binago niya yung 0 times 1, biglang naging 0. But if you look at 1, if you multiply 0 and 1 by 1, parehas yung naging sagot, right? Walang pagbabago. You can also look at the columns. So ito 0, 1, minultiply ko by 1, ang naging sagot 0 by 1 din. Naulit lang yung row header, walang nangyari, so 1 is the unity. All right? So 0 is the 0 and 1 is the unity. What is the additive inverse of 0? Di pa lang nagpa-quiz tayo ngayon, no? Sayang. So ano ang additive inverse ni 0? Gawa tayo ng table. So
Is it
additive inverse. Additive inverses. So si A, negative A, 0, 1. So sino si negative 0? Ano ang additive inverse ni 0?
Itself po.
Yes, it's 0.
0, sir.
Right? Thank you, guys. Yeah, it's 0. Because, paano tayo naghanap ng additive inverse? Kailangan hanapin ko sino yung i-add ko kay 0 para makuha si 0. So, punta ako kay 0. Sino dapat yung i-add ko sa kanya para makakuha ko ng 0? So, you look at the row across 0. Kailan ako nakakuha ng 0 pabalik? Kailan ko nakuha yung additive identity? Maybe we should note the additive identity here. Additive identity ay 0. So kailangan hanapin ko dito sa naka-green, sino dyan yung nagbigay ng, kailan nagkaroon ng 0? Nagkaroon ako ng 0, and how did I get a 0 inside the table? When I added 0 to 0. So the additive identity of 0, the additive inverse of 0 is 0. How about the additive inverse of 1? Sino si negative 1?
1, sir.
1. Thank you,
0.
Ian, Richard, Jason. Mukhang try again, Becky, kung si Becky man yun. So the answer is 1. Kaya pwede nyo isulat na negative 1 is equal to 1 in Z2. Totoo tong equation na to kay Z2. But if somebody will see this in your notes, they might be thinking you're crazy. Because why do you say negative 1 is equal to 1? Well, you can tell them, nag-linear algebra ako. Ang negative 1, ang interpretation ng additive inverse ni 1 kay Z2. Kapag ka nag-add ako ng 1 kay 1, ang sagot ay yung additive identity na 0. Alright? So, if you're looking at it on the table, so you go to since I'm looking for the additive inverse of 1, I look at 1. Kailan si 1 magiging 0? Ano dapat yung i-add ko kay 1 para makuha yung additive identity? Ang additive identity ay 0. So you look at the row across 1. Titingin ako dito. Right? Kailan nagkaroon ng 0 dyan? Dito. Ano yung in-add ko kay 1 to get this 0? I added 1. So negative 1 here is equal to 1. All right? All good?
Sir, question?
Yes, go Richard.
Yeah, so can we say, sir, na hindi unique yung additive inverse ng field na to?
Okay. Yeah. Just some technicality there. Ang additive identity, ang additive inverse ay isang property nung mga numbers dun sa set. Yung additive identity ay isang property nung field. So when I say, what's the additive identity of the field? So isang number lang yung sagot. Kasi unique ang additive identity. Kasi ang additive identity at ang multiplicative identity, sila ay nakatali as properties ng field. Pero yung inverses, yung additive inverse at saka yung multiplicative inverse, sila ay mga properties na nakatali pa isa-isa dun sa mga numbers. So additive inverse ni 0 ay si 0, additive inverse ni 1 ay 1. So bawat isang number doon sa field, may kanya-kanya silang additive inverse. So if you are asking kung ang mga additive inverse ba ng mga members ng field ay iba-iba, yes, posible silang iba-iba. Pero it's a little technically wrong if you say that the additive inverse is not unique. Unique siya per element. Pero yung additive inverse ay posibleng magkakaiba para sa bawat isang element ng set. Kasi nga, ang additive inverse, chine-check siya element by element. Yung additive identity, chine-check siya para dun sa buong set. I hope that clarifies things. So lalo ba nakagulo?
So thank you. It answered my question. Thank you.
All right, you're welcome. Okay, so punta tayo sa multiplication. Oh, by the way, guys, it's already 8, and I guess I scheduled it 7 to 8. But kung gusto nyo, pwede nating ituloy probably until 9 if you want. But you're free to go out of the session if you need to go or kung pagod na kayo. Yung recording naman, kapag-record ba ako? Yes, I recorded the session, so it will be available to you guys anyway. So pero masaya lang na may kausap habang nagdi-discuss para hindi ako parang nagmo-monologue dito sa bahay. Right, let's try to do it for multiplication. Yes.
Good evening po, Sir Neil. Alright, sorry po, I guess nakapasok po ako 6:57. Sir, di ba yung symbol po kanina a while ago is rational numbers? And ano po nga po ulit yung implication ng 2 doon po sa kanina po, doon sa previous slide po? Ayan po. That there are 2 elements po, sir.
Yeah. Actually, ano lang siya. Yeah. This is z. So, para siya sa integers. Z sub 2, lahat ng mga integers na less than 2. Or dalawa lang yung laman niya starting from 0. So, 0 and 1. Yeah,
Alright.
because later, yeah, tama Rose. Kasi later magkakaroon ako ng Z4. Halimbawa, ito naman yung 0, 1, 2, 3. Okay. So, pero later pa natin i-define yung mga Z subscript. Hindi ko pa ito na-define, so you're good. Wala ka pa namang na-miss.
Thank you po, sir.
All right. So again, I think we have identified earlier that the multiplicative identity is 1, right? Equal yan kay 1. So ang unity ng Z2 ay 1. Let's look at the inverses. A, gawa ko ng table. A at saka A inverse. So 0 at saka kay 1. Ano ang multiplicative inverse ni 0?
0.
0.
Nope. Try again.
Ay.
None. Tama si Becky. None. Di ba hindi required na magkaroon ng multiplicative inverse yung 0? Yeah. Tapos paano natin kinukuha multiplicative inverse? Hahanapin natin dun sa table kung kailan naging multiplicative identity yung sagot sa multiplication, right? So if we go at 0, hahanapin ko ngayon kailan lumabas yung multiplicative identity dun sa row niya. Ang multiplicative identity natin ay 1. Kailan nag-appear si 1? Never. So wala siyang multiplicative inverse. And that is fine because 0 is the 0 of Z2. Siya yung additive identity. Hindi siya required to have a multiplicative inverse. Clear? Okay. Okay, magalala. Ginugulo ko lang kayo para masanay kayo sa mga ganyang tricky questions. Okay, now what's 1 to the negative 1? What's the multiplicative inverse of 1?
1/3.
Great. All right, very good guys. So 1. Kasi again, kung ang hanap natin ay multiplicative inverse ni 1, pupunta ako dun sa mga sagot. Dun sa multiplication by 1, hanapin ko kailan nagkaroon ng unity. Dito siya nagkaroon ng unity. How did I get that? I used 1. So that is 1. All right? Okay, madali yan kasi dalawa lang yung elements. Madaling tingnan yung multiplication table. So, indeed, as I've mentioned earlier, Z2 together with this addition and this multiplication is a field. And then if you look at it symbolically, Z2 consisting of 0 and 1 ay subset, quote-unquote, ni R, right? Kasi si 0 ay naka R, si 1 ay naka R. So you can think of it as subset si Z2 ni R. So does it make addition Z2 together with this addition and multiplication a subfield of R? What do you think, guys? Yung mga nakabasa ng modules, alam na yung sagot. Pero what do you think?
Hindi po, sir.
Yes, why, Raf?
Kasi po, yung operations na ginamit is different from the for real numbers at saka sa Z2.
Okay, great. That's exactly why Z2 is not a subfield of R. Kasi tama si Raf, yung addition at multiplication na ginamit ko rito ay hindi yung kaparehas na addition at multiplication kay R. Kasi halimbawa, sa real numbers, ang 1 plus 1 ay equal kay 2. Pero dito sa operation kay Z2, ang 1 plus 1 natin ay 0. Alright? So, ibig sabihin, dahil dun sa isang yun lang ba yung pinagkaiba? Yes. Dahil dun sa isang pagbabago dun sa addition na yon, hindi na siya naging subfield. Right? Yung multiplication, wala tayong problema yan. Kasi this is the same multiplication table for 0 and 1. Kaya lang yung addition ay naiba. Kasi yung 1 plus 1 natin dito ay iba mula dun sa 1 plus 1 mula sa set of real numbers. So, and also, Z2 is a different structure than the set of real numbers. Hindi natin siya tinitreat as a subset of R kasi algebraically, iba yung 0 na to dun sa 0 ng real numbers. Iba yung 1 na to mula dun sa 1 ng real numbers, and they behave differently because they are governed by different operations. So nagkataon lang na parehas yung symbols nito dun sa 0 at 1 na nakay R. Pero we'll talk more about that later. I just want to show kung kailan hindi nagkakaroon ng subfield. Okay? All right, questions? Okay, wala pa naman. Okay, the next example ay sa complex numbers naman. The set of complex numbers together with addition and multiplication defined below ay isang field din. And I think there's a proof here of being a field. So remember, the set C, the set of complex numbers, ay set ng mga numbers ng itsura ay real number plus real number times the imaginary constant I or the imaginary unit I. So lahat ng elements ni Z ay pwede nating isulat in this way. All right? And then the addition and multiplication are defined as follows. So ang Z1 plus Z2, kailangan ko makita ano yung itsura ni Z1 at ni Z2 when I write them in their expanded representations. So halimbawa si Z1, ang itsura niya ay A plus BI. Tapos si Z2, kunwari ang itsura niya ay C plus DI. Oh, by the way here, A is called the real part ni Z1. This is the real part of Z1 kasi siya yung real number na nag-iisa. All right? And then B is called the imaginary part. Kasi siya yung imaginary part kasi siya yung nakamultiply dun sa I, dun sa imaginary unit na I. Right? So, dito naman sa Z2, ang real part ay si C, ang imaginary part ay si D. Okay? Now, addition of complex numbers are defined as follows. Yung Z1 plus Z2 ay equal sa, i-add lang natin yung real parts, sila yung sum ang magiging real part, plus i-add mo naman yung imaginary parts times I. Okay? That's how we perform complex addition, where the addition here and the multiplication here are the usual addition and multiplication from the real numbers. Meanwhile, Z1 plus Z2 is a little trickier. The real part of Z1 times Z2 is AC minus BD, and the imaginary part is AD plus BC. Pero alam ko tinuturo nyo to to be parang FOIL method, ano? Pag nag-multiply ka ng A plus BI times C plus DI, FOIL method ka lang. Yan, 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 yan. Alright? So magkakaroon ng AC plus ADI, tapos BIC plus BD, pero magkakaroon ka ng I squared, so negative 1 yun. So magkakaroon ka ng AC minus BD plus AD plus BC, and that's how we got this formula over here. Okay, so FOIL method lang siya. Ginamit lang din yung property na I times I ay equal kay negative 1. Okay, now if this is our addition and multiplication, then C would be a field together with these two operations. Okay, now in writing a proof, you first mention na yung addition at saka multiplication ay mga binary operations kay C. Because when we add two complex numbers up, and if we multiply two complex numbers, the answer are still complex numbers. All right? So binary operations sila talaga. Tapos, ipoprove ko yung associativity. So how do we prove associativity? I will use the property ng associativity ng real numbers. So remember, pag nagpo-prove ng associativity, gusto mong ipakita na ito ay equal sa Z1 plus Z2 plus Z3. Yan yung goal natin, right? Para kailangan natin ipakita yung unang equation sa definition 1, condition 1. Right? So yung 1.I natin or 1.1 natin. So we want to show that the grouping doesn't matter. So sa pag-prove ng equation, na totoo yung equation, you start with one side of the equation only and use valid steps in order to come up with the other side. Bawal yung ginagawa natin probably dati nung elementary na halimbawa nagpo-prove ka ng gusto mo i-prove ng AI equal kay B. This is what you want to show. Meron tayo dating konsepto na, okay, pwede ako mag-work dito, lagyan ko lang yan ng question mark, tapos magpe-perform lang ako ng operations on both sides, halimbawa AC, BC, and so on, hanggang mapalabas ko yung gusto kong magkaroon ako ng 1 equals 1. Halimbawa, tapos lalagyan ko siya ng check mark dyan. So, dati ganito yung ginagawa natin. Pero if you're doing technical math already, hindi na pwede yung ganyang pagsusulat ng proof. The idea is you start with one side of the equation, all right? Isang side lang yung galawin mo, tapos ipakita mo na makukuha mo yung other side. You either select the left-hand side and then work para makuha yung right-hand side, or the other way around. Or kung hindi yon kaya, ang pwede mong gawin ay i-simplify yung left side, then i-simplify yung right side, separate from each other, and then show that they will be equal to the same thing. Yun yung dalawang paraan ng pag-prove ng isang equation o ng isang identity. Alright, so bawal na yung yung nagwo-work agad ng naka-equation siya, tapos saka ka gagawa ng operations. Because you are then assuming na totoo na kagad yung gusto mong i-prove, which is not the case. Gusto pa lang nating i-prove na totoo yung statement o yung equation. Right? And that's what I did here. I started with one side nung definition 1.1 o property 1.1. So kunin ko muna yung Z1 plus Z2 plus Z3. Alam ko si Z1 ang itsura niya ay A plus BI by the definition kanina. Si Z2 ang itsura niya ay C plus E. Yeah. Si Z2 ay C plus DI. Tapos si Z3 ay E plus FI. Right? Tapos mag-start ako dito, isi-simplify ko to, at ito-try ko na makita na equal to sa quantity Z1 plus C2 plus Z3. Okay? Now, how will I do this? Well, kunin ko muna ito. Kailangan ko muna itong i-simplify, right? So this is C plus DI plus E plus FI. Kailangan ko itong i-simplify. Well, if you follow the definition, i-add mo lang yung mga real parts nila, i-add yung imaginary parts nila, you get the sum Z2 plus Z3. Okay? And that's how you got this. Yan yung sagot sa Z2 plus Z3. All good? Diyan pa ba kayo?
Yes,
Yes,
sir.
sir.
All right, good. And then now, I will simplify this into the larger expression. All right? So, ano ang real part? So, dalawang numbers lang to, no? Ito yung pangalawang complex number, ito yung unang complex number. To get the sum of these two complex numbers, I just need to add the real parts. Ito ang real part niya, ito ang real part niya. So, ito ay A plus quantity C plus E. Plus, i-add ko naman yung imaginary parts nila. Imaginary part ay B, imaginary part ay D plus E. So that's how I got this guy, tapos lalagyan ko lang siya ng I. Ganon yung definition ng addition. Okay? And then, ang target ko, mapakita ito ay equal sa Z1 plus C2 naka-enclose sa parentheses plus Z3. Okay? Alam ko kung anong itsura niyan. So, I'll just be working backwards. So, gusto ko magka-group muna si Z1 at saka si Z2. So, ganun yung i-arrange ko lang etong sagot na to para mag-conform doon sa form ng Z1 plus Z2 quantity plus Z3. Alright? So, ang gagawin ko ngayon, instead na ganito yung grouping, mag-a-apply ako ng associativity ng addition ng real numbers. Kasi si A, si C, at saka si E, mga real numbers lang sila. Yung addition na to ay usual addition of real numbers. So, since associative naman ng addition of real numbers, I can regroup terms so that I have this. Makikita nyo mamaya kung bakit gusto ko siyang i-group that way. And then similarly here, this is just addition of real numbers. Real numbers are associative. Addition is associative on real numbers. So I can group B and D first, and then saka ko na i-add yung F. That's how I got this. All right? Sir, bakit mo gustong gawin yon? Kasi nga, gusto ko na ihiwalay yung Z3. So, tingnan nyo itong E, tapos itong F, pwede ko siyang hiwalay kasi Z3 yan. So, matitira na lang ako ng A plus C plus B plus D times I dito sa first term. Alright? And what is this guy? Ito ay Z1 plus Z2 plus Z3. So, what I have shown here is that Z1 plus the quantity Z2 plus Z3 ay equals sa Z1 plus Z2 first before adding it the answer to Z3. Okay? So indeed, associative ang addition. Does that make sense?
Yes,
Si
sir.
Judy lang nag-react. Ayan, si Robbie, si Marin. Yes, Richard.
I mean, yeah, it makes sense. Thank you.
Okay, akala ko may tanong ka. Yeah. Well, medyo ano to, no? Medyo may konting aha moment dito sa gitna ng proof because I expanded the sum into this guy, ano? And then out of the blue, I decided to, hold on, pagpalitin ko yung grouping nito. Sorry, dito pa pala yun, no? So sinimplify ko siya rito and then seemingly out of the blue, I wanted to group A and C together at i-separate si E. Ganun din dito, bakit ginusto kong i-group si B at saka si D at i-isolate si F? This is because I have the foresight of how Z1 plus Z2 quantity plus Z3 will look like. So alam ko na kasi yung target ko, kaya nire-ready ko na yung form para doon sa gusto kong maipakita. But if you cannot see it that way, one alternative way of doing it is, okay, kunin mo tong Z1 plus Z2 plus Z3, kunin mo to, you'll get this guy. Ano? That's straightforward. And then another thing that you can do is simplify this first. So nagawa mo na to. Pwede mo yung gawin, set it aside. And then separately, you simplify this guy. Pag sinimplify mo, makukuha mo to. Tapos makukuha mo ito. So, and then you compare the two answers that you get, and if you can conclude that these two are equal, then you can say na, eto rin, at saka eto rin ay equal, because they are equal to the same thing. So that could be another approach if you cannot present it or package the proof in this way. I guess somebody has a question. Sino muna?
Can you please get it, Tin? Thank you. Sorry.
Yeah, sino yung may question? I think somebody has a question. Rose Kawayat.
Yes, sir. Sir, is it okay to, to reason out that the use of factoring in BI and then the quantity of D plus FI, since actually the complex number is a common, can we use the justification there to come up with the target, since the intention is to show that the associative property for addition is true?
Yes, you can do that. Although, minsan ina-avoid natin yung paggamit ng terms na hindi pa na-define or hindi pa nagagamit before, like factoring. Kasi there was no mention of factoring earlier. Although, strict application yun ng axiom of ignorance. Kasi sa math nga, yung axiom of ignorance, ang alam lang natin ay kung ano yung nasusulat. Ano yung naturo at ano yung define, ano yung inassume. But sige, you're free to use other properties that you have learned before or that you had been using before. Okay, so that's also fine.
Thank you po.
Okay, all right. And then, similar yung proof ng associativity, mas mahaba nga lang. Kindly just read it and see if you can parse through the entire thing. It's a little bit more involved computationally kasi mas mahaba naman talaga yung formula ng multiplication kaysa sa addition. But I started here at Z1 times the quantity Z2 plus Z3. I tried to simplify it. Ito yung naging final answer niya. And then I use some properties of commutativity and associativity of addition of real numbers, and then distributivity played a role in here until I come up with Z1 times quantity Z1 times Z2 times Z3 to show associativity. So medyo mahaba. Pero siguro yan yung isa sa mga homework nyo, not to be submitted, is to read the associativity proof of multiplication. Similar to sa addition, mas marami nga lang operations ang kailangan gawin bago sila mas-simplify. But again, medyo mas mahiwaga yung gagawing pag-group para mapakita yung equality ng quantity Z1 times Z2 times Z3 at ng Z1 times quantity Z2 times Z3. Well, what you could have done here is simplify this first hanggang dito. Okay? Then set it aside. So pakita mo yung Z1 times Z2 times Z3 ay equal dito. And then hiwalay. So set that aside. Another part of the proof is to compute saan equal yung Z1 times Z2 times Z3. And then you can do that. Mapapakita mo equal din siya dito. So the two guys being equal to the same thing means that the two guys you begin with are also equal to each other. Then you're good. You have proven associativity. Okay? Okay lang ba if I leave the reading of that part to you guys?
Yes, sir.
Yes, right, sir. Thank you. And then yung commutativity ay mas simple kaysa sa associativity, Talaga mas mahirap yung associativity. May nakapag-start na nung homework? Ginawa niyo ba yung associativity problem doon? Medyo super haba pala no? I'll review it and tingnan ko. Let me know via email or via the forum in Moodle kung kumusta yon. Kasi kung masyadong mahaba at masyadong mahirap, I can exempt you from doing that probably. Pero kailangan mo nang i-review yung answer key ko, ano? Kasi hindi ko natanda kung ano nga, kung mahalaga ba yung associativity doon. I'll need to check.
Sir,
So, yes.
parang na-try ko po yata yun. Yung associativity of addition, number 1 pa, sir?
Aha. Mahaba ba masyado?
Item 1 po ba, sir? Item 1.
Sa item 1. Either item 1 or item 2 yata yung may isang ganun.
Apo. Sir, yung multiplication, yung associativity on multiplication, yung parang feeling ko po medyo mahaba. Kasi nga, ay mahaba po talaga siya.
Yeah,
Yung
hindi siya
sagot.
mahaba. Mahaba siya talaga. Tanda ko kasi yun, reklamo sa akin yun ng mga estudyante ko last time. Eh. So sige, babasahin ko yung answer key and then I'll let you know via the forums, ano, or via an announcement. Yes, Aline, may question ka?
Ayun po, Dok. I think trinay ko lang siya i-solve yung homework number 1. Parang umabot siya ng 2.5 pages. Kasi kada property, ginawan ko siya ng ganun. So parang hindi ako sure if tama ba yun kasi ang haba talaga.
Yeah. So, at ginawa ko rin siya nung answer key. So, yeah, it's a tie for us. Ano? So, pero tingnan natin. Ano? May mga nakagawa na pala. So, dapat lahat pala tayo ay maghirap para doon. Ano? But anyway, let me think about it and then balikan ko yung answer key. All right. Commutativity is much easier because you're just working with 2 elements at a time. We just need to show that flipping the order of addition and multiplication doesn't matter. So here, Z1 plus Z2, simplify ko lang. So wag yung i-equate yan kagad sa Z2 plus Z1. Do not start your proof by saying that Z1 plus Z2 ay equal kay Z2 plus Z1. And then you simplify this, and essentially you get the same thing. Hindi siya yung tamang pagsusulat ng proof. This is wrong because whatever you write on the proof should be something that is already known to be true. When you start your proof by saying that Z1 plus Z2 is equal to Z2 plus C1, you're already saying that what you need to prove is already true. You cannot use whatever you want to prove itself. It's as if you're walking into court saying that the accused is guilty because he is guilty. Hindi ganun nag-work, ano? So, kailangan yung gawin ay mag-start ka sa isang side, C1 plus Z2, then use some arguments, simplify mo yan, hanggang makarating ka sa Z2 plus Z1. Or, pwede kang mag-start sa Z1 plus Z2, i-simplify mo siya hanggang sa kaya mo, tapos, on a separate part, i-solve mo yung Z2 plus Z1, i-simplify mo siya hanggang sa kaya mo, at ipakita mo na itong nasa dulo ay equal dun sa nasa dulo, saka mo i-conclude na si Z1 plus Z2 ay equal sa Z2 plus Z1. Right? So I hope that's clear, ano? So laging kailangan namin yung i-correct pagpasok ng mga estudyante, ano? And then ganun din naman ako nung high school. Ganun din kami nagpo-proof. So pero kailangan natin siyang i-correct, ano? Kasi sa formal proof, lahat ng nasusulat dapat sa proof ay either assumption or something that is already proven to be true. Okay? Now, dun sa proof ng commutativity, maybe let's do multiplication this time. Kasi kanina addition yung diniscuss natin. So, kailangan ko lang sundin ano yung formula para sa Z1 times Z2. Ito yung binigay dun sa definition dun sa example. And then I want to show that this is equal if I will apply the formula, but this time Z2 times Z1. Well, will you just use commutativity of multiplication? Yung AC, susulat ko as C times A. Yung BD, susulat ko as D times B. Yung AD, susulat ko as DA. And yung BC, susulat ko as CB. Just commutativity of multiplication of real numbers. And then if you will check how Z2 and Z1 will look, how Z2 times Z1 will look like after you apply the definition of multiplication, you will see that this is exactly this guy. And so you have proven that Z1 times Z2 is equal to Z2 times Z1. Okay? Mas madali yung commutativity. Right? Any questions? Okay. Property 3, distributivity naman of multiplication over addition. Well, ito, gusto ko yung ipakita ay equals sa Z1 times Z2 plus Z1 times Z3. All right. Again, you will start with only one side of the equation. You start with this guy. So, kunin ko muna yung Z2 plus Z3. Ito yon, dito siya equal. Saka ko siya ita-times sa A plus BI using the definition. Okay? Now, anong mangyayari? So, na-add ko na siya. So, i-multiply ko naman tong dalawa na to. I'll get this. So again, straightforward application of the definition of multiplication. And then, since it is difficult for me to rearrange the terms so that this will look like a Z1 times Z2 plus Z1 times Z3, what I did here is the second alternative method of proof or presentation of the proof. Ito yung sinasabi ko kanina na paghiwalayin natin sila, paglaruan natin sila ng magkahiwalay, and hopefully we can show that they are equal to the same thing. So dahil na-stuck na ako dito, wala na akong maisip na magandang gawin dito para mapakita na siya equal sa Z1 times Z2 plus Z2 plus Z1 times Z3, kinompute ko na lang ito ng hiwalay. So meanwhile, I solve for this. Simplify mo yan, simplify yan, computation, computation. So dito, in-apply ko lang ng paulit-ulit yung equation 16 and 17, yung definition ng addition at multiplication ng complex numbers. So Z1 times Z2 is this guy, Z1 times Z3 is this guy, and then we need to add them up. So we get that. And then, pag nag-add ako ng dalawa na to, ito daw yung sagot. And then, I'll just simplify them using properties of addition on real numbers, further simplification, and essentially, we will be able to show that this, this is something similar, something familiar, because that's where we ended up the simplification for Z1 times Z2 plus Z3. Okay? Dahil ito ay nandito rin, pero alam natin ay ito ay equal sa dun sa kinompute natin kanina na Z1 times Z2 plus Z3, then we can say that multiplication of complex numbers is distributive over addition of complex numbers. Okay? That good?
All right.
Yan, tahimik na yung iba. Pero I'm seeing thumbs ups here, so that's good, I think. And then ito naman, additive identity. So ang additive identity ay sino yung number na i-add natin sa kahit anong complex number para ang sagot ay yung complex number pa rin. The obvious candidate is 0, which can be written as 0 plus 0i. All right? Bakit si 0 plus 0 times I yung iniisip ko as additive identity? Kasi si 0, siya yung additive identity under the set of real numbers or for the set of real numbers. Yung addition lang naman ng complex numbers ay ina-add natin yung real parts, which are both real numbers, at ina-add ko yung imaginary parts, which are also real numbers by themselves. So it makes sense na ang hula natin for the 0 of the set of complex numbers to be 0 plus 0i. Kailangan nyo nga lang i-prove na totoo na pag in-add mo si 0 plus 0i sa kahit na anong complex number Z1, ang sagot ay si Z1 pa rin. Well, and that's easy to prove, right? Because here, I'll just show that any complex number Z1, when added to 0, which our guess is 0 plus 0i, ay equal pa rin kay Z1. Okay. Alam natin ang itsura ni Z1 ay A plus BI. Tapos ang candidate natin para sa additive identity ay 0. Siya ay 0 plus 0i. And then, when we add them together, we simply add their real parts plus we'll add their imaginary parts times I. All right? Pero ano ang A plus 0? A plus 0 is simply A, right? Kasi si 0, siya yung 0 ng real numbers. B plus 0 is still B. So B lang ito. So B times I. And who is A plus BI? That is exactly Z1. So Z1 plus 0 is equal to Z1. Then, indeed, 0 plus 0i is the additive identity. Okay? Good? Ganon din kadali yung sa multiplicative identity. Ang unity, ang hula ko sa unity ay hindi pala ito madali. Kasi maraming pwedeng candidate. Ano? Kung ifa-follow mo yung pattern kanina, one possible guess is the unity is equal to 1 plus 1i. Kasi kanina 0 plus 0i, sir. So malamang 1 plus 1i din yan. But if you check, 1 plus 1i cannot be the unity. Kasi hindi niya ma-preserve yung multiplication. The real identity or the real unity, the real multiplicative identity is 1 plus 0i. And here's the proof why 1 plus 0i is the multiplicative identity. I'll get another arbitrary complex number, say z1, equal to a plus bi, and I will multiply it to 1 plus 0i. So a plus bi times 1 plus 0i, i-apply nyo yung formula 17, yung definition ng multiplication. So pag minultiply ko to, remember, pwede ako mag-FOIL method actually. A times 1, you get that? B times 0 times I, so that's just gonna be B times 0 pero may negative sign, so that's how you get negative B. And then bi times I, so you get B times 1 times I. And then here you get B times 0 times I squared. So, sorry, ito na pala nasa dulo. A times 0 times I, you get that guy. So pag in-apply mo yung multiplication, ito yung makukuha mo. But A times 1 is A. B times 0, real numbers lang yung pinag-multiply natin. So alam natin ang real number times 0 ay 0. So we'll get A as the real part. And then the imaginary part is A times 0, that's 0 plus B. 0 plus B is just B, BI, which is exactly C1. So here we see that if we multiply Z1 by 1 plus 0i, the answer is still Z1. So that means the multiplicative identity here is 1 plus 0i. Okay? Tapos ito na. Any questions about that? Problema lang, sir, paano na-derive yon? So siguro later, kapag ka-komplikado yung expression, mahirap makuha yung multiplicative identity. But here, I have a guess that it's either 1 plus 1i or 1 plus 0i. It turns out that 1 plus 0i siya yung tama by checking if z1 times 1 plus 0i will give me back c1. All right? Siguro later when we look at some more complicated fields, saka natin tingnan kung paano nasosolve yung multiplicative identity. But it's just solving for equations. So medyo mahaba nga lang yung solution. Okay? All good? Or too much na for one sitting? Yan,
Okay, sir.
Mukhang paunti nagta-thumbs up. Mukhang nagbukas na kayo ng Netflix dyan. Yes, Rose.
Sir, may tanong po ako. Doon po sa additive inverse and multiplicative inverse po, para masabi nating unique siya, it should be equivalent to 1?
Inverse or identity? Ano yung tanong mo, Rose? Identity or inverse?
Yung multiplicative inverse po and then yung additive inverse, para po ma-establish po natin yung uniqueness, it should be equivalent to 1. For example, for multiplicative inverse, dapat po ma-establish po natin na equivalent sa 1 para po masabi natin unique.
Yes. Pero hindi mo kailangan ng uniqueness sa multiplicative inverse. Kailangan mo lang mapakita or hanapin ano yung number na pag minultiply ko dun sa isang number, ang sagot ay 1. At usually, isa lang talaga yung makukuha mo doon. Actually, may theorem. Yeah. Actually, may theorem. I don't know kung ipoprove siya or nasa homework. Parang wala naman sa homework. Pero siguro later, ipoprove natin na kung merong multiplicative inverse ang isang number, yun ay unique. Isa lang ang multiplicative inverse ng bawat element ng fields at yung proof para doon ay proof by contradiction. I-assume ko na may dalawang multiplicative inverse kasi papakita ko na yung dalawang multiplicative inverse na yan would in fact be the same number. So proof by contradiction yung kailangan ko ron. Pero yeah. Pero usually computationally, para makita nga yung multiplicative inverse, i-equate mo sa 1 yung product, tapos isosolve mo kung ano yung pangalawang number, tama? At unique yung makukuha mo. That's another thing. But the formal proof will require a proof by contradiction. We can show that. We can give an example later. All right?
Thank you po, sir.
All right. Yung pang limang property, ang daming properties, no? Para makonclude na isa siyang field. So, additive inverse, medyo madali lang naman yung additive inverse para makuha yung negative Z1. Para makuha yung negative Z1, kailangan ko lang hanapin ano yung i-add ko kay Z1 para maging multiplicative, para maging additive identity yung sagot. So what should be added to Z1 to get the additive identity that we have discovered earlier? So 0 plus 0i, di ba yung additive identity? So sino yung i-add ko kay Z1 para makuha yung 0 plus 0i? It turns out that it is just the exact negative of the complex number. Right? So i-negate mo lang yung additive yung real part, i-negate mo lang yung imaginary part, you will get the additive inverse. Right? Because if you do so Z1, ito siya, yung negative, ang hula natin sa negative Z1 siya ay negative A minus BI, right? Tapos pag in-apply mo yung definition 16 or yung equation 16, it will just be A plus negative A, which is just 0, plus BI plus negative BI, which is just B plus quantity negative B times I, that will just be 0. So 0 yung sagot. So, ibig sabihin tama. Ito yung additive inverse. Medyo mahirap yung multiplicative inverse. Ito yung hula kong formula para sa multiplicative inverse. So, pag meron akong A plus BI na hindi equal kay additive identity, hindi siya equal kay 0, which is 0 plus 0i, ito yung itsura ng inverse niya. Okay. At makikita natin na talagang itong formula na to ay hindi mag-a-apply kay 0 plus 0i. Kasi pag si 0 plus 0i, ang z natin, so ibig sabihin ang a natin ay 0, ang b ko ay 0, etong denominators ay magzi-0. So we can't really use this formula for 0 plus 0i, the additive identity. But that is good, or that's fine, because we don't need 0 to have a multiplicative inverse. So kaya pwedeng ito yung hula nating formula. Right? Kasi hindi kailangan masatisfy ito ni 0 plus 0i. Now to check if my guess for the multiplicative inverse is correct, what I'll just need to do is to multiply Z1 by Z1 inverse, by my guess for Z1 inverse. Dapat ito ay may subscript na 1. Okay, pakidagdag sa notes nyo. So gagawin ko lang, multiply ko lang si Z1 dun sa hula ko para kay Z1 inverse. Alright? I-apply si formula 17. Pag in-apply si formula 17, ito yung makukuha nyo. But this would be a squared minus minus, so you'll get a squared plus b squared all over a squared plus b squared. So that's how you got this pag sinimplify nyo yan. Tapos ito, pag sinimplify nyo ito, inad nyo, magiging 0, alright? Times I, so bababa si I doon. And what is this? This is just 1 plus 0i, which is we know to be the multiplicative identity. So indeed, pag minultiply ko to kay Z1, makukuha ko yung multiplicative identity. So ito na nga ang inverse under multiplication. Ito yung multiplicative inverse ni A plus BI. Computing them will be a different thing. And due to lack of time for tonight, I will skip that. Siguro next tutorial, I will tell you, or probably I'll upload the video na lang para pwede niyong panoorin at your own time para mas marami tayong ma-discuss next tutorial. I'll tell you how I got that. Pero usually, ano lang naman yun solution lang ng equation. So what I did there is to guess. Ginawa ko lang na A plus BI times C plus DI, inequate ko lang sa 1 plus 0I, and then I solve for C and D. Ano ko akong C ay ito. Ano ko akong C ay, ito yung nakuha kong C, ito yung nakuha kong D. Right? Sorry, wala yung I. So ito yung nakuha kong D. Hold on, hindi ko siya mabura. Yeah, there. Tinakuha ko hindi. Reverse engineering lang para makuha ko yung sagot. And then once I do that on a scratch paper, I will just present in the proof this multiplication over here, just to justify that my ansatz or my guess for the inverse of C1 is indeed the multiplicative inverse. I do it this way. But if you're wondering, how did I get this? I solved for this on the scratch paper. And you don't need to show that solution because all that matters is really the proof. Then when you multiply C1 to your guess or to your presented inverse will be equal to this guy. Okay?
Sir?
All right.
Sir,
Yes, go. So, yes.
So, ganun din po sa identity. We do not need to show how we got the identity. We can simply show na, ayun na nga, if we operate that on an arbitrary member of the element of the set, we get the same element. So, sa scratch paper na lang po yung pag-derive namin ng
Yes.
identity at ng... Okay, thank you, sir.
Yeah. Sa parang part 4, ganito lang yung kailangan ko. Hindi ko na kailangan malaman paano yun, bakit ito ang hula mo or bakit ito yung hula mo para dun sa identities. That's fine. Yeah, para mukhang ano, ito yung parang mistake or something that makes your solution look more matalino, ano? Kasi parang out of the blue, bakit ito yung hula niya na identity? Bakit ito yung hula niyang unity? So everything was done on paper. Everything was done on a scratch work. And we don't really need to see that. The magicians do not usually reveal their trick. Ano? So, ganito lamang. Pwedeng ganito na ipakita nyo because that is all that is required. Paano nyo nakalap yung ebidensya? Sa inyo na lang yan. Pwede nyo nang itago. Kailangan ko lang makita na, totoo. Itong hula niya, yan yung multiplicative, yan yung additive inverse. Additive identity at multiplicative identity. All right? Now, I will just leave example 3 to you guys to read. This is just an example when you're working with a very different operation. So here you have the set of complex numbers, and then nag-define lang ako ng kakaibang operation on them. Eto, ganito ko i-define yung addition of two complex numbers, which is essentially, actually, I think there's a typo here. A plus B. Yeah, this should have been a D. So, sa equation 19, pabago, dapat ay A plus C plus quantity B plus D times I. So, yung addition, sa example 3 ng complex numbers ay kaparehas ng addition ng complex numbers, ng usual addition ng complex numbers. Ang pinagkaiba lang nila yung multiplication. So ang Z1 times Z2 dito sa example 3 ay ganito yung itsura. Meron ditong extra factor na P, where P is a fixed constant, a fixed prime number in fact. So pipili ka na. Halimbawa si P mo ay, ano ba mga example ng prime? Halimbawa ang gusto mong P ay 2. So mag-insert ka lang dito ng P. So medyo kakaiba yung definition dito ng multiplication than example 2. This is not the usual multiplication on the complex numbers. Yung usual multiplication ay yung defined sa example 2. But example 3 will just give you an idea that even if you have the same set, you can define other operations on that set and still come up with a field. Right? So, posible yon na kaya importante na i-declare nyo kung sino yung kasama nung set as a field. Alright? So, katulad dito, iba yung operation, iba yung multiplication. So, magkakaroon ka ng kakaibang field kaysa dun sa field together with the usual addition and multiplication. Dito, yung field natin ay field, same complex numbers. Ang kasama niya ay addition, the usual addition. Pero kakaiba naman yung multiplication niya. That's why here we use different symbols. Yung addition niya ay plus sub P at saka multiplication sub P. Alright? So I'll let you I'll let you work on that. Siguro the last 10 minutes for this session. Tingnan natin yung example number 4. Kasi ito yung medyo, let me see. Yeah. Ito yung tingnan natin. Example number 4. Although, mas okay yata gawin natin to in more details. Hold on. Yeah, maybe I'll start and then see what we can have for the next 10 minutes. We'll end it at 9 kasi masama naman na masobrahan tayo ng math Saturday night ngayon, ano? So, and this might be probably too much for one sitting. Pero not all fields are infinite. Katulad ng mga complex numbers, real numbers, rational numbers. Meron din mga fields na finite lang yung members. Nakita na natin kanina si Z2, right? So, yung mga C sub P, where P is a prime number, ay field din, right? So, ano si C sub P? Ito yung tanong kanina ni Rose. Ang C sub P ay nag-start kay 0 hanggang makabuo ka ng P members. So, 0, 1, 2, hanggang kay P minus 1, where P is prime. And then the addition and multiplication are defined a little differently. So ang addition ay tinatawag nating addition modulo P. So you take the sum first, A plus B, and then you modulo P it. Ang ibig sabihin lang ng modulo P, you take the remainder after you divide by P. Kunin mo muna yung A plus B, tapos i-divide mo kay P. Kung ano yung remainder, yun yung sagot dun sa addition modulo P. Sa multiplication, ganun din. Kunin mo muna yung A times B, tapos i-divide mo kay P. Kung ano yung remainder, siya yung sagot sa multiplication modulo P. Alright? Nagawa niyo na ba to? Modular arithmetic before? Or hindi pa?
Not yet, sir.
Then, nagawa niyo na yan sa pagsasabi ng oras. Halimbawa, though medyo, medyo synthetic yung example, pero halimbawa nasa 49 seconds. Tapos magdadagdag ka ng 12 seconds. So ano na yung second na actually magke-carry over ka na pala, no? Hindi pala siya magandang example. Pero pag meron ka ng halimbawa nasa 149 ka na, mag-a-add ka ng 12 seconds. Ano na yung sagot? 201, right? Tama ba? 201. Yeah, 201. Pero, so, ibig sabihin yung 49 plus 12, naging 01 na yung sagot. So, this is probably an example of modular arithmetic, although medyo synthetic yung approach. Pero sige, illustrate na lang natin. Gawa tayo ng operation table. Pero yung maliit lang siguro para magkasya sa 10 minutes. Let me add a page here. So gawin natin, tapos ito na rin yung exam. Dito tayo mag-start next meeting. Siguro let's start with Z5 para medyo mas maraming elements. Ano? Ang Z5 ay kailangan ko ng 5 members starting from 0, 0, 1, 2, 3, and 4. Tapos maggawa ko ng operation table. So gawa ko ng operation table for addition. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Then, copyhin ko lang to para sa multiplication mamaya. Okay. Okay. Addition. So, let's do the addition. So, 0 plus 0 is 0 divided by 5. So, ang P natin dito ay 5. So, if I want 0 plus 0, kukunin ko muna yung sum nila. So, ang sum nila ay 0. I-divide ko by 5. Ang sagot ay 0, remainder 0. So, this is still 0. Okay. And then 0 plus 1 ay 1. Divided by 5 ay 0, remainder 1, ang sagot ay 1. Do you guys follow? So, okay. So, ganyan din yan. Tapos, alam ko naman, 1 plus 0 ay 1, 2 plus 0 ay 2, 3 plus 0 ay 3, 4 plus 0 ay 4. Okay? Ang shortcut ay, pag hindi lumampas ng 4, yung sagot sa addition, then that is still the answer. Okay? So, halimbawa, 1 plus 1, ang sagot dyan ay 2. Ang 1 plus 2 ay 3. Ang 1 plus 3 ay 4. Pero dito na, 1 plus 4 sa totoong buhay ay 5. Alright? The answer is 5. Pero 5 divided by 5 ay 0, remainder 0. So ang 1 plus 4 sa Z5 ay 0. Agree? O, si Robin na lang yung nag-guess. Yeah, Jason. Okay. Oh, there you go. That's good. So 2 plus 1. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. Lampas na siya. 2 plus 3 is 5. So the answer is 5. Divide mo by 5. That's 1 remainder 0. So the answer is 0. Yung remainder, yung nagiging sagot. Tama? And then 2 plus 4 ay 6. Lampas na ng 4. So hindi siya pwedeng maging sagot dun sa operation table. Kasi ang sagot lang dapat nagsisimula kay 0 hanggang kay 4. So kailangan ko itong i-divide by P, which is 5. The answer is 1, remainder 1. So ang sagot sa 2 plus 4 ay 1. Right? So ito na yung mga kakaibang math kung kailan ang 2 plus 4 ay hindi 6. Ang 2 plus 4 ay equal kay 1. Right? So 3 plus 1 is 4. 3 plus 2 is 5. Lampas na sa 4. So hindi ako pwedeng maglagay dyan ng 5. Kasi ang sagot lang dapat ay 0 to 4. So kailangan ko ngayong i-divide. 3 plus 2 is 5. Divided by 5 is 1. Remainder 0. So this is 0. 3 plus 3 will be 1. Sorry. Tama ba? 3 plus 3, 1. Yes. 3 plus 4 ay 2. 4 plus 1 ay 0. 4 plus 2 ay 1. 4 plus 3 ay 2. And then 4 plus 4 ay 3. That's the operation table for addition modulo 5. Okay? And then from here, we can see that this is repeated here, right? So, ibig sabihin, si 0 yung additive identity. Right? Kasi doon na ulit yung top row. Right? Or pwede mo rin tingnan kung hindi ka pa sure kung commutative yung operation, tingnan mo rin yung column. Yung 0, 1, 3, 4 is a repetition of the row headers. And then if you look at their intersection, ito yung multiplicative. Ito yung additive identity. So the additive identity is 0. Okay? Tapos tingnan natin. Gawa tayo ng table ng A at saka negative A para sa additive inverses. 0, 1, 2, 3, 4. Sino ang additive inverse ni 0? Sige. Sino ang negative 0?
Zero po.
0, sir.
Great.
0 siya.
Good. Negative 1. Sino si negative 1?
4,
Good. Negative 2.
3,
3,
3. Great. Negative 3.
2,
2,
Okay. Negative 4.
1.
1.
Good. So, yan yung paggagawa ng additive identity. So, yeah. Titingnan nyo lang kung kailan naging 0 yung sagot dun sa row, right? Or ano yung shortcut sa modulus? Anyone who saw the pattern? Paano nahanap yung negative ni A?
Kapag pinag-add 5.
Yes. Pag pinag-add mo sila, dapat P yung sagot. Yung usual addition, dapat 5 yung sagot. Yun yung yun yung additive identity. Okay? So that's the shortcut. Yun yung para hindi na kayo pupunta dun sa operation table. Right. Let's work with the multiplication now. So gawin natin yung multiplication modulo 5. Ganun pa rin. Kapag ka hindi lumampas ng 5 yung product, yun na yung sagot. Hindi mo na kailangang i-divide by 5 muna. So, gawin ko muna yun. So, this would be 0, 0, 0, 0, 0, 0, 0, 0, 0. Tapos ito ay 1, 2, 3, 4. 2, 3, 4. 2 times 2 ay 4. And I guess that's it. So, dun sa rest, kailangan ko na mag-divide. What is 2 times 3? Sige nga. 2 times 3?
1,
6, so 2 po.
Hindi 2. Tama
One.
yata si
One.
Ian kanina. 1. Yeah. Di-divide nyo by
Ay,
5
1 pala.
and remainder
By
yung
0 pa
sagot.
pala.
Yeah. Ay baka nakikinig yung mga anak nyo dyan tapos pinagtatawanan tayo, ano, nagto 2 times 3 tayo, 1 yung sagot natin. So kasi ibang ano tayo, no, ibang field. So 2 times 4?
2.
No.
I
3, sir.
2
3.
sir.
3, sir.
Three.
Tama, 3.
Yeah, you'll get the hang of it, ano. So keep those guests coming in. 3 times 2 ay 1. 3 times 3.
1, sir.
4.
At
4.
4.
4. 3 times 4?
2.
2.
2. Yes. 4 times 2, nasagot na natin to kanina. 3. 4 times 3, nasagot na rin kanina na 3 times 4. 2. 4 times 4?
1.
1.
0. 1.
1.
1, sir.
Okay. So anong multiplicative identity?
1. 1.
Yeah, it's 1. Kasi tingnan niyo yung row ni 1 at column ni 1. Naulit lang itong nasa ibabaw at yung nasa kaliwa. Alright, so that's the multiplicative identity. Now, gawa tayo ng table sa inverse. Oops. Ako ng A, saka negative, A to the negative 1. 0, 1, 2, 3, 4. Ano ang reciprocal ni 0?
None.
What is 0 inverse? None.
None.
Okay.
None.
Inverse ni 1?
1.
1.
Ano ang 1 over 2? Or the multiplicative inverse of 2?
3.
3, sir.
3. Kasi ang 2 times 3 ay 1, right? 2 times 3 ay equal kay 1. That makes 3 the inverse of 2. What is the inverse of 3?
2.
2, sir.
2,
2.
right? What's the inverse of 4?
4.
4, sir.
Great,
4.
4. Kasi ang 4 times 4 ay equal kay 1. Okay, and then we can check later we can prove the other properties of being a field. Ano lang naman to kasi kung mapapansin nyo, yung addition modulo 5 at multiplication modulo 5 ay nakadepende dun sa addition at multiplication ng real numbers. Kasi paano natin kinocompute yung addition mod 5? Ina-add muna natin lahat, tapos yung sagot, i-divide ko by 5, kukunin ko yung remainder. Sa multiplication modulo 5, i-multiply ko muna using usual multiplication lahat ng numbers. Tapos yung sagot, i-divide ko by 5, kukunin ko yung remainder, yun yung sagot. So both addition and multiplication modulo 5 are very dependent on the properties of usual addition and multiplication. And then so that I think that is sufficient to argue that it is associative, it is commutative. Multiplication modulo 5 is distributive over addition modulo 5. And then, napakita na natin na merong additive at multiplicative identities. Tapos lahat ng elements may additive inverse. Lahat ng non-zero elements ay may multiplicative inverse. So therefore, addition modulo 5 is a field. All right. Now, something to think about is bakit kaya required na si P ay maging prime number? Kasi halimbawa, pwede niyong paglaruan pag wala kayong magawa or hindi kayo makakatulog mamaya, gawa kayo ng operation table ni C6 under addition mod 6 and multiplication modulo 6. Bakit hindi siya field? Kasi ang pinrove lang natin ay in theory or ang binanggit dito sa example, kapag si P ay prime, sure tayo na siya ay field. All right? Pero pag hindi siya field pag hindi siya prime katulad ni 6, hindi na siya field. So si C6, gawa kayo ng operation table kahit multiplication, makikita nyo na hindi talaga siya field. Kasi pag tinignan mo yung multiplication table ni C6, may kulang sa kailangan ng pagiging field. Okay? So tingnan nyo mamaya, bakit kaya? Ano yung kulang para kay C6? Ang clue ni Sir ay ang gawa ko ng multiplication table ni C6. Makita nyo doon, kaya hindi pala siya pwedeng maging field. Pero hindi lang pala mga primes meron ding mga hindi primes na magkakaroon ka pa rin ng field. Katulad ni Z4. Si Z4 ay isang field. Kahit si 4 ay hindi prime. Kasi sinabi ko lang kanina, pagka si P ay prime, ang C sub P ay field. Wala akong sinabi na dapat maging prime si P para maging field siya. I'm just saying one part. So kapag ka si P ay prime, si C sub P ay field. May example tayo kay 5 na pag hindi siya prime, hindi na siya field. Pero may mga P na hindi prime na nagbibigay pa rin ng field. Halimbawa si Z4, siya ay isang field. Si Z8 ay isa ring field kahit si 8 ay hindi prime. Si Z9 ay isa ring field kahit si 9 ay hindi field. Actually, ang kailangan ay power of a prime. Kapag ka meron kang Z, tapos ang subscript mo ay prime raised to a power, siya ay nagiging field pa rin. Pero probably question number 6 is more advanced. Titingnan niyo yan sa abstract algebra, pero a nice question is yung number 5. Okay? Okay, so probably that's too much math for one sitting. Especially this might be the first time you're seeing this very weird addition and multiplications. So let's continue our talk about the module. Let's schedule something up early next week. Kaya lang pag-isipan ko pa
Sir.
kasi medyo tricky yung scheduling natin. But before I go there, Rose, question?
Apo. Sir, pasensya na po, madami akong pong tanong. Sir, ano po no, hindi ko lang po na-umpisahan kasi yung kanina. Tama po ba na assumption po na magiging field siya if yung associativity and then yung commutativity ay true po for that particular asset.
Yes.
Kaya po yung Z6 hindi po siya mako-considered as field kasi it would be impossible for us to have yung magiging identical for the row and identical for the column.
Actually, sige, spoil ko yung part ng sagot sa number 5. Associative ang C6. Associative ang addition at multiplication kay C6. Commutative ang addition at multiplication kay C6. Meron ka distributive ang multiplication over addition kay C6. Meron kang additive identity, which is 0. Meron kang multiplicative identity kay C6, which is 1. So, okay yung mga properties na yun. Ang problema yung inverses. Alright? So, if you make an operation table, para kay multiplication, makikita nyo na hindi lahat ng elements ay may multiplicative inverse kay C6. So, yun yung magiging problema niya. So, yeah, associativity and commutativity will not be a problem for C6. Ang problema yung inverses. So, try to make a multiplication table kay C6 para ma-identify nyo sino yung mga elements ni C6 na hindi magkakaroon ng multiplicative inverse.
Okay po, sir, get it po. Thank you so much po.
Yeah. Ayan, inispoil na tayo ni Ian. So, yeah, 2 and 3. Si 2 at saka si 3. Si 2 and 3 nga lang ba? Si 4 yata wala ring multiplicative inverse. Nagawa ka na ba, Ian, ng table?
Hindi pa po tapos, sir.
Okay. I think si 4 wala din. Si 4 ay wala ring multiplicative inverse. So, yeah. So, you guys try that. That would be a nice exercise. Yeah. So, let's schedule something para ipagpatuloy natin yung discussion. And this would be the exciting part where we start proving some things para rin ma-jumpstart yung paggagawa nyo ng homework number 1. And since homework number 1 involves a lot of proving, maybe let's move the deadline for homework 1 probably siguro until Saturday or Sunday next week para makapag-meet muna tayo at least once para makapagbigay ng examples ng proving. So we'll try proving some parts of proposition number 1 para masanay kayo para sa pagpo-prove. Kasi halimbawa, tingnan niyo yung property number 3. Sa proposition 1.3, 0 times an element of the field is equal to 0. And you'll be thinking, bakit pa kailangang i-prove ito? Ang 0 times a number, alam ko na naman yan na ay laging 0. Hindi nyo tinanong yung elementary teacher nyo kung bakit ang 0 times 1 ay 0. Bakit ang 1 million times 0 ay 0 lamang. Dito, ipoprove natin na ang 0 times a number ay laging equal kay 0. And we are doing it in a more general sense, hindi lang para sa mga real numbers. Papakita natin na basta nasa field ka, kahit ano pang field, ang additive identity times any member of the field ay laging equal kay 0. And then if you look at some other properties, it will really feel weird that we need to prove them, like proposition 5 or proposition 1.5. Ang negative ng negative A ay equal kay A. Sa real numbers, alam natin yan kasi parang ano lang siya, negative ng negative A is positive A, right? Pero we don't read it that way in abstract algebra or in theoretical math. We read it as the additive inverse of the additive inverse of A is equal to A itself. So ganun mo siya babasahin. Proposition 1.6, ang additive inverse ni A, pag minultiply ko sa additive inverse ni B, ay equal lamang sa A times B. So it's a little different if you look at them as numbers versus when we think of them as elements of fields. So yun yung gusto kong i-emphasize when we start proving some parts of proposition 1 before you do the homework. All right? But I guess this is a good time to start. I held you up for 8 more minutes than intended. Any questions, any burning questions, or anything you want to share before we leave the meeting? Okay.
No more, sir.
Yeah. Okay, so if that's the case, I wish that you keep up the questions or more questions more people will ask questions next time. Mas gusto ko yung maraming tanong kaysa yung nagbo-monologue lang ako, no? So keep those questions coming up. Let's schedule something probably on Tuesday or Wednesday para meron kayong enough time to study for the homework, which will be due on gawin nating Sunday next week. Yeah, Judy, you have a question.
Sir, would it be possible if we meet po GC po sa Messenger para mas mabilis po yung communication? If okay lang po sa'yo, sir.
Yeah, sure. That will be good. Paano natin siya magagawa? Lahat ba kayo ay may Messenger or something? Yeah, if that is fine with everybody, so you can contact you can contact everyone and then pa-add na lang ako dun sa GC ano. So full name ko naman yung nasa Facebook ko, so you can add me there. Para nga naman mas mabilis ano. Yes, other concerns? Yes, Aline?
Hello po, Doc. I can initiate po the GC po. Kasi may
Okay.
iba pong classmates ako sa previous SEM na mayroong GC kami. So, pwede ko silang ma-add sa new GC po. Including you
All right.
po.
Yeah, that's great. Thank you, Aline. And then add na lang tayo. And then let me know if hindi pa kayo na-add, and then ako na lang yung mag-add sa inyo. Sol, another concern?
Sir, yung abstract algebra po namin ay nag-schedule na ng online sessions on Tuesdays and Thursdays, 7 p.m. So maybe we can
Okay.
take yung ibang araw.
Yeah, we
Or
can
ibang
probably take
oras,
the Wednesday, ano?
Yeah. Okay.
Hindi ba talaga kayo pwede ng work hours? Parang walang nagsasagot ng from 9 to 5, ano? Yeah, so kung wala talaga, sige. So, off hours tayo mag-meet. So, most probably Wednesdays and Fridays. I don't know if you guys want Saturdays, but yeah. Yes, sino pang may question? Si Raf, nakita ko nag-raise hand or binaba niya kagad. Okay, other concerns, questions? So if there are none, it was a good first tutorial. Let's keep the pace going. Keep those questions coming. Thank you for joining us tonight, and enjoy the rest of the evening. Enjoy the long weekend, and let's see each other again probably on Wednesday. I'll make an announcement when. All right. Bye, guys.
Thank you,
Thank you
sir.
po.
Thank you, sir.
Permission to leave,
Thank
sir.
you, sir.
All right. Yeah, go ahead. I'll end the meeting na rin for everybody.